Let's take another LPP problem and solve it using graphical method. So here we'll have to minimize. Objective function is given, constraints are given. We have two constraints given here, and we will have to plot the graph. So what's our step now? What's the next step? We'll first get the points, right? So we'll take constraint 1, right? What is constraint 1? X plus 3y greater than or equal to 3. This is our constraint 1. Now we'll have to substitute x is equal to 0 and obtain y. So when x is equal to 0, we'll get 0 plus 3y is equal to 3. We'll assume that it is equal to 3 so that we get the point. So this will give us y is equal to 1. So we have our first point. What is first point? 0 and 1. Now we'll do the same thing. Put y is equal to 0 now. So we'll get x plus 3 into 0 is equal to 3. So what do we get? X plus 0 is equal to 3, or x is equal to 3. What is our second point now? 3 and 0. Let's call this as point A and point B. Now let's take the second constraint. What is second constraint? X plus y greater than or equal to 2. This is our second constraint. Take x is equal to 0, we'll get y is equal to 2. Take y is equal to 0, you will get x plus 0 is equal to 2, which is x is equal to 2. Now let's take this point, point C. X is 0, y is 2. Point D, x is 2, y is 0. So we have our 4 points here. Now we will have to plot these points in the graph. Now let's roughly plot it here. So the points are 1, 2, 3. Okay, so we'll take a scale of, we'll take units with a gap of 1. So let this be the origin. 1, 2, 3, 4, 5. Similarly, 1, 2, 3, 4, 5. So let's take the first point, A, which is 0, 1. 0 on the x-axis, 1 on the y-axis. So this is our point. This is our first point, A. And our second point is B, which is 3, 0. 3 on the x-axis and 0 on the y-axis. So we get this one. So this is B. Now let's join these points. So we get constraint 1. What is constraint 1? X plus 3y greater than or equal to 3. This is our constraint 1. Let's plot third point, 0, 2. So 0 on the x-axis and 2 on the y-axis. So this is our next point, C. What is the fourth point? 2, 0. So this one. So let's join this. So this is our constraint number 2, which is x plus y greater than or equal to 2. So we have obtained 2 lines here. Now what is the next step? We'll have to find the feasible region. Let's do the shading. Let's take constraint 1. It is greater than or equal. So whenever the limit is greater than, the shading will be outwards, away from the origin. When you say outwards, above the line, this way. This is the first constraint. Yeah, above the line. Now let's take the second constraint. This is also greater than. So again, this has to be above the line, away from the origin. Let me take a different color. So the shading will be like this. Now, when you say above the line, it can keep on going above. There is no limit. So let me extend the shades so that I can see the overlapping region more visibly. Right? Now, where do you see the overlapping region? Do you see it here? No. Do you see it here? No. So the overlapping region is appearing here, this portion. Right? So the overlapping region is here. This is the overlapping region. So we have point C, B, and there is one intersecting point. We'll have to arrive at this point value. So if we have plotted it accurately, we'll get the exact value. So the point is somewhere, x-axis, I think this is 1.5 and this is 0.5. So we have the point as, let's call it as E. E is 1.5 and 0.5. So this is our intersecting point. So we have 3 corner points now. Let's write the corner points. First one is C 0, 2. Second one is B. B is 3, 0 and intersecting point, which is E 1.5 and 0.5. So we have our corner points. Now what is the next step? We got the feasible region. This is the feasible region. Now we'll have to arrive at feasible solutions. So let's get the feasible solutions. How do we get the feasible solutions? We have to take the objective function and substitute each of these points. So let's take the first point, 0, 2. Let's substitute in z. So what do we get? 3x plus 4y. So this is x and this is y. So 3 into x is 0 plus 5, y is 2. So we get 0 plus 10. We get 10. Now let's take the second point, 3, 0. So we get 3 into x is 3, y is 0. So we have 5 into 0, which is 9. The third point, 1.5 and 0.5, 3x. So 3 into 1.5 plus 5 into y, y is 0.5. So we'll get 4.5 plus 2.5, which is 7.0. So we have got our feasible solutions. We have 3 feasible solutions. Now let's arrive at optimal solution. Optimal solution. Optimal solution Z is, we'll have to take minimum of all these 3 values because it's minimizing the objective function. So what is the least of these? It is 7.0. So Z min is 7.0. It occurs at which point? 1.5 and 0.5. So this is our value for minimizing the objective function.